Kirkleman. Welcome, ladies and gentlemen. We are here at Module 12, and we are going to talk about variables, two different variables, or relationships with two variables. All right, so the first lesson that we have for Module 12 is reviewing tables and graphs. So you might have done some of this in 5th grade, so we're just going to review a bit of it. I know in class we've talked a bit about it as well, so this is just kind of a review about using tables and graphs. So in this video, you're going to learn how to graph an ordered pair on a coordinate plane in the first quadrant, and you're going to be able to write an ordered pair given a table or a graph. Okay, so here are our vocabulary words. The coordinate plane includes two perpendicular number lines that intersect at the origin. And the origin is that 0, 0, right in the middle. So a coordinate plane can look like this, where these are both number lines. This is a vertical number line, and this is a horizontal number line, sorry. And the middle right here is 0, 0. So that means that it's 0 horizontally and 0 vertically. The horizontal number line is called the x-axis, and the vertical number line is called the y-axis. So this is x, and this is y. Each point on the coordinate plane is described by an ordered pair, which determines its location. So if I had a dot here, and let's say that dot was A, that is an ordered pair. It's determining its location on this graph. Ordered pairs are written x, y, like this, where the first value describes the x coordinate, and the second value describes the y coordinate. It just means the first value describes where it is on x, and the second value describes where it is on y. Okay, so here is some practice. Feel free to pause and do this on your own. Otherwise, we can do them together. A couple things, you do need to know your shapes to do this. So we should know circle, triangle, square. Hexagon has 6 sides. Pentagons have 5 sides. Trapezoids have 4 sides and can look like this. And a rhombus is kind of like a diamond. It has 4 sides, but it looks like a diamond. Okay, so if I am looking, let's get a little darker color here. At the circle, this is my circle point right here, and I am first going to do x. So I'm going to find its location on x, which is 2. And then I'm going to look on y, and I'm going to move over on y and find its location on y. And remember to put those points in parentheses. So I'm going to pause the video, and I want you to do the rest of the shapes and then join me to see if you did it correctly. All right, so here are all of our ordered pairs. Some that get a little bit tricky are making sure that your hexagon and your pentagon have the right numbers because they look similar and they are very close on the number line. And then, of course, our kite here, our rhombus, it is a 0 and then a 5. And that is because we always start our graphing here at the origin at 0, 0. So if I start here and my first number is 0, it means I'm going to go nowhere. I'm not going to go right or left. Then my second number tells me how high up to go up, and that's where we get our 0, 5 from. Okay. Now we're going to answer some questions about our points. It says, describe the difference between the ordered pairs for the hexagon and the pentagon. These are our ordered pairs for our hexagon and our pentagon, and you may notice that they are flip-flopped. They are backwards. Okay. Basically, it's x and y are reversed. So the y came down here, and the x came down here. And so even though they use the same numbers, they both have a 4 and a 3. The hexagon has its 4 first because it's 4 on the x, whereas the pentagon has the 3 first because it's 3 on x. Be very careful with numbers like this because order does matter. X always comes first before y, And there's lots of ways to remember this, but one of them is that X comes before Y on the alphabet. If you sing the alphabet, X comes first, so you always remember to go side to side first. The second question that we have on here says, Yvette is asked to plot the point 7, 0 and places it on the y-axis, which means it would be along here on the same spot that, or in the same line that the rhombus is located. Did Yvette plot the point correctly and justify your thinking? Well, we just talked about how X always comes first, so that means I should have gone to 7 first and then not moved and gone to 0. So it really should be on the x-axis, not the y-axis, okay? And the reason for that is because 0 tells us not to move. So whichever letter is 0, the opposite letter is what axis our point is on. So if y is 0, it's on the x-axis. If x is 0, like it is in our rhombus here, it's on the y-axis. All right, so now that we know how to plot ordered pairs on a coordinate plane, we're going to look at plotting pairs from a table. So we've got horizontal tables and we have vertical tables. And when you have a table, you're going to be given sets of numbers. And we want to know, how do I plot these points on a coordinate plane? How do I plot things in a table? Well, the left column table always represents the x coordinate, while the right column always represents the y coordinate. So this is always, left is always x and right is always y in a vertical table. In a horizontal table that goes from side to side, x values are on the top and y values are on the bottom. So just like when we graph, we always say x comes first. You can think of that in our tables too. The first row is x because x comes first. The first column, reading from left to right, is x because x comes first. So when we look at a table like this or a graph, I can take points from this graph and place them in my table by looking at my x and my y and where it meets on the line that they gave me. So here you can see that 5, if x is 5, then y is 10. And it has to do with where it hits this line on the graph. If x is 10, then y is 20. And you'll probably start to see a pattern because we have a straight line. Straight line graphs usually have a pattern to them. If x is 15, then y is 30. If x is 20, y is 40. And if x is 25, y would be 50. Okay, so that's how we fill out a table from a graph. And then on this side, we're going to do the opposite. We're going to take the points that are given to us in this horizontal table, and we're going to plot them on the graph. So remember, the top is always x. So minutes is our x, and remember to label your graph, your axes. And y is always on the bottom, so y is our rotations. Rotations. And then we just have to put our numbers in. And the nice thing about graphs like this is usually if your table is skip counting by a number across and a bottom, then you can just use the numbers from your graph. Otherwise, you would have to figure out, how do I go up to 15 on the bottom and up to 60 on the side, and you would pick a number to skip count by there. They don't have to be perfect. 12, 3, 6, 9, 12, 15, 18, 21. Okay, and then on the side here, we're going to go by 12s. Actually, to fill out our graph a little bit, let's actually skip count by 6s. It'll just make our graph fill in because we have 10 spots available. And that way our graphs kind of spread out over this table a bit. There we go. And now we're just going to plot our points. 3, 12, 6, 24. Remember doing x first. 9, 36, 12, 48, and 15, 60. So now you can see our graph kind of takes up the whole top and bottom. If I had skip counted by 12s, I would have ended up kind of here. And it would have been a really small, short little graph. So this just kind of spreads it out. I could have chose to skip count down here by maybe 4s, but it actually would have made it a little smaller. If I had skip count by 2s, I could probably fit everything on here as well. So I could have skip counted by 2s here. It's just my points wouldn't have been perfect. So if you can make something easy for yourself, do that. All right, so now let's practice here. So I've got Donald's Donuts sells sprinkled donuts. At the end of the day, Mr. Donald attempts to determine how many donuts were sold, but is missing some information. Use the information in the table and the graph to help him. So it gives us some information in our table and some information in our graph, and we have to fill in the rest. We know here 12 donuts is sold for $30. So I can fill in this column right here, 12 and 30. Now for the rest, I might have to be a little creative because my dots are not perfect on a spot, so it's kind of hard to read exactly where that number is. I can estimate, but I do need consistent information. One way to do that is to find the unit rate. What if I sold 1 donut? Where would my dot be? How much would its price be? So to find a unit rate, I just divide. So let's take an easy one, like 30 divided by 12. Okay, 12 goes into 30 times. 12 goes into 30 2 times, which is 24. 12 goes into 60 5 times, so that would be 2.5 right here. So I can buy 1 donut for $2.50. So what if I buy 7 donuts? Well, I could try to use my chart and estimate, but I'm not quite sure where my dot would go. So instead, let's do 7 times 250. And let's see where our answer is. 7 times 5 is 35. 14, 15, 16, 17. So that would be $17.50. So if I was at 7, which is about here, 7, 8, yep, I would go up to about 17, 15, 16, oh, there's 5, 15, 16, 17. So our dot would be about here, okay? Then let's go up to 20. Well, I could also, if I wanted to, I could keep multiplying by 2.5. But another thing I could do is say, well, how do I turn a 5 into a 20? 5 times 4 is 20. So let's do 1250 times 4. And that will get me my answer here. So let's see, 1250 times 4. 4, 8, 9, 10. 4. That's going to be $50. I could also, so then 20. So if I had an income of 20, it's going to be right here, and we can estimate that to be about 8. We could also add 250 here, if one more would be 0, and then that's it, that's $20 even. So you kind of have to use a little bit of the table and graph, but a little bit of your unit rates and ratios to solve your problem. Use the table and the patterns in the table to help you, and your knowledge of ratios to help you as well. So you're going to work on something to practice this. Good luck.